Hello there. It's time for another basic science lesson, and today we'll be looking at the chemical symbols of elements. Now, the objective of this lesson is to help learners define elements, describe chemical symbols of elements, state the ways chemical symbols of elements are derived, and state the first 20 elements and their symbols. So then, what is an element? Now, an element is a substance that consists of only one kind of matter or atom that cannot be broken down into simpler forms. Now, examples of elements are iron, zinc, copper, iodine, oxygen, and so on. Now, you have examples here as shown in this picture right here. We have silver, carbon, bromine, sulfur, mercury, and chlorine. And therefore, you should be able to state the state of matter that all these elements occur in, and you must be able to tell whether they are metals or non-metals. Now, moving along, we'll be looking at chemical symbols of elements. Now, elements are usually represented by symbols rather than their names. A chemical symbol is a letter representing the name of an element. Now, we have examples of elements here and their symbols. Now, you have capital letter C and L symbolizing chlorine, capital letter H and small letter E for helium, capital letter C for carbon, capital letter O for oxygen, capital letter A and small letter L for aluminum, and so on and so forth, as you see in this picture right here. So now we're going to be looking at ways chemical symbols are derived. Now, every element has been given its own symbol. Now, first, for some elements, the symbol is a single letter, which is the first letter of the element's name. That's the first way by which we derive the symbol of elements. For instance, we have capital letter H for hydrogen, capital letter C for carbon, capital letter O for oxygen, capital letter S for sulfur. So the symbol is always a capital letter. Now, other ways by which symbols of elements are derived is usually from the first letter of their names, followed by either the second or third letter of the element's name. For instance, helium here, we have capital letter H and small letter E, which are the first two letters for the element helium. We have capital letter A and small letter L for aluminum. But in the case of chlorine, you can see chlorine is symbolized using capital letter C and small letter L, which are the first and third letters of the name. In the case of silicon, the first two letters of the name silicon serves as the symbol. Now, moving along, finally, we'll be looking at another way in which chemical symbols are derived. Now, in this case, in the other elements, we use the letters from their English names. But in this fourth case, the symbol of silver, for example, comes from the Latin word argentum, which is, of course, Latin for silver. And many other symbols are derived from the Latin names of certain elements. For instance, we have aurum, which is the Latin name for gold, and the first two letters here serves as the symbol Au. In the case of lead, the Latin name is plumbum, and the symbol is Pb, which is derived from the Latin name. In the case of sodium, the Latin name is natrium, and the symbol is derived from the name of from the Latin name of sodium. In the case of iron, the Latin name is ferrum, and the symbol is Fe. Potassium, the Latin name is kalium, and the symbol is K. Now, moving on, we'll be looking at the periodic table of elements. Now, the periodic table of chemical elements, often called the periodic table, organizes all discovered chemical elements in rows called periods and columns called groups, according to increasing atomic number. Now, as you can see here, the periodic table here shows the first 20 elements. So you can see that you have, rows and columns in the periodic table. These are the rows. These are the rows that you have right here. In this case, we have 4 rows. And how many columns do we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 columns right here, and we have 4 rows, which makes up the first 20 elements of the periodic table. Now, as you can see, hydrogen here has the atomic number 1, helium the atomic number 2, and it goes on and on. So you can see that as you move from the first row to the second row, you can see that there's a steady increase of the atomic number as you move from one element to another in the periodic table. And that's why hydrogen is 1, because it has an atomic number of 1, and calcium is 20 because it has the atomic number of 20. So you can see the arrangement right here. In senior class, when we are looking at chemistry, we'll be able to describe why we place these elements in rows and columns. In other words, in periods and in groups. We will explore that, but for now, the periodic table here shows the first 20 elements and their symbols. Hydrogen has a symbol H, helium He, lithium Li, beryllium Be, boron E, carbon C, nitrogen N, oxygen O, fluorine F, neon Ne, sodium Na, magnesium Mg, aluminium Al, silicon Si, phosphorus P, sulfur S, chlorine Cl, argon Ar, potassium K, and calcium Ca. Now we have come to the end of today's lessons. Now let's take a quick look at the summary. Now, an element is a substance that consists of only one kind of matter or atom that cannot be broken down into simpler forms. Examples are iron, zinc, copper, iodine, oxygen, and so on. A chemical symbol is a letter representing the name of an element. There are 4 ways of deriving the symbols of elements. The periodic table of chemical elements, often called the periodic table, organizes all discovered chemical elements in rows called periods and columns called groups according to increasing atomic number. Now, before we go, I want you to pause this video and I want you to answer these questions right here to see how much of the lessons that you have imbibed, and I'll see you again in the next lesson. Bye bye.